Hi students, and welcome to lesson 3 from topic 8. Today we are talking about what the book is calling the initial value. And just like last time where they called rate of change, they called slope rate of change, I'm going to introduce initial value as something slightly different than what the book is going to be showing you. Just because this is a super important concept and I want to make sure that it's super clear for you to use in the future. So we are going to use this diagram that they have given us, but I'm not going to go through the Pearson lesson per se. I'm going to show you it in a different way. So basically what we're working towards our understanding here is a type of equation that is called slope-intercept form. And I'm going to type that out here. So slope-intercept form. And slope-intercept form is a type of equation where we have y equals, lowercase y equals mx plus b. And we're going to talk about what all this means in a little bit, but I want to make sure that this is something you know and that you're aware of, that you have to memorize this formula. You need to know what this is called, and you need to know this equation right here, y equals mx plus b. And the reason why you need to know this is because this is the standard form of an equation, or it's a type of form of an equation that you will use for the rest of your math life. So you can take any equation written in this form and very easily graph a line from it. And vice versa, you can look at any line that's graphed and very easily write it in slope-intercept form. So it's something that you're going to use a lot in your 8th grade math career, as well as your high school math career and beyond high school as well. So let's go ahead and break down this term for a little bit here. So in our slope-intercept form, you can see that we have two words. We have slope and we have the words intercept. I'm trying to keep the colors the same as what they used over here on our screen. So we learned about slope yesterday. Remember, we learned that slope is, I'm going to write slope notes here. So slope is rise over run. Rise over run. Or we can say the change in y's, or the difference in y's, the change in y over the change of x. And then there's a formula for it that we kind of jumped ahead to, but I want this to all be on your notes for today. So it's y2 minus y1 over x2 minus x1. Okay, so all of these ways, there's 1, 2, 3 ways to find slope. These are all different ways to find slope, and the slope is represented by the letter m. So slope is represented by the letter m in our equation. Okay, and now we need to talk about the intercept. And just like if you watch football or maybe you play football, if there's an interception, it means that you have caught the ball instead of someone else. You intercepted the ball, and that means that you've crossed in front of it and you've taken that interception. So when you have a graphed line, you're looking for when you're talking about the intercept, you're talking specifically about the y-intercept. Where does the y-intercept intersect that blue line? And for here, it's right here on this point. And so you're specifically looking for the y-intercept. So where does the graphed line touch the y-axis? All right, and that's what you're looking for in intercept. So if we write notes about intercept, if you're looking at the intercept, you are looking at the y-intercept. And so you're going to ask yourself, let me actually type this because it'll be faster here. Where does the graphed oops, let me make a space here. Where does the graphed line touch the y-axis or axes? That's what you're going to ask. And the coordinate is always going to be 0, something, because it's always going to be at 0 here, and then this one's like at 0, 1. And let's see that, get rid of here. Okay, so those are your two pieces of your equation. So we have, let me go back to this. We have our slope and our intercept, and our intercept is always represented with the letter B. I don't know why, it just is. But do not get this confused with the y that's over here. There is always going to be an x and a y in your equation because you need to be able to use your equation to generate x's and y's. Like if we were filling in a table or if we were trying to get coordinates, you always need your x and your y in your equation. But your slope is going to need a number here, and your intercept is going to need a number here. For example, an example of an equation, let me change colors here so we can follow along, would be y equals, and the slope, maybe we could do the slope of 3. We still need our x in there because that's what's going to help us with our equation, 3x plus, and the intercept, let's do 2. So if I pull up a Desmos page here, and I type in that equation, y equals 3x plus 2, I've got my graphed line here. So remember, my slope is 3, so I would expect to have to rise 3 and run 1. So I'll start at a perfect coordinate. I'm going to rise 1, 2, 3, run 1. Here's my next perfect coordinate. Okay, or if I'm doing the whole numbers here, we can zoom in a bit. If I'm doing whole numbers instead of these tiny grids, I could do rise 1, 2, 3, run 1, and here's my next perfect coordinate. Okay, and then my intercept is 2, so that means I expect my red line to touch this black y-axis right here on 2, and sure enough it does. It touches right here on 2. All right, so that is why slope-intercept form is super helpful, because we can super easily say, here's the equation, here's the line. Yep, they match. And vice versa, if we wanted to see the line, we could say, okay, well, here's the line. Where does it intercept? Okay, that's my B. 2 is going to be my B. And what is the slope? Rise 3, run 1. Okay, my slope is 3. And you can just plug it back in, and you can say, oh, well, if I needed to write an equation, I could say my equation would be y equals, the slope was 3, x, and the intercept was 2. And I can have my new equation written right away for me. Okay, so this lesson is calling the y-intercept the initial value, because it's kind of, initial to me means the word is similar to the word start. And it is where it starts on the y-axis right here, but it doesn't mean that it doesn't continue on down to the left as well. So that's why I don't like the word initial, and I'm going to call it the y-intercept. Just know that on your homework you probably will see it as initial value, but for me I'm going to refer to it as the y-intercept because it simply is the place where the line intersects that y-axis right here. Okay, so we're going to jump into our first part, and I do think we'll be able to cover this lesson in one video. I hope so, at least. And let me jump over one more time here. Actually, no, we'll stay on this one. We're going to drag each linear function to the initial value. So what we're basically asking us, what is the y-intercept in these equations here? So we have y equals 3x minus 2, y equals 3 minus 3x, y equals negative 3x plus 2, and y equals 2x plus 3. There's 3 equations here that are written in slope-intercept form. If you notice, this one is not. This one is written kind of switched. The 3x needs to be right next to that equal sign. This minus 3x needs to be right next to the equal sign. So we'll deal with that in a minute. So let's start with the ones here. 2 is the slope. 3 here is the initial value, or the y-intercept. So we're going to move that to 3. Here we have negative 3 as the slope. Positive 2 is the y-intercept. We're going to deal with that one later. Here we have 3x minus 2. So this is interesting. Remember our form. Our form is y equals mx plus b. So if you see a minus b, that means that b is negative. So we have to remember that the equation is supposed to be positive. So if this is a minus 2, our intercept is negative 2. Now if you picture moving y equals 3 minus 3x, let me write it on here for us. Y equals 3 minus 3x. Our 3x is supposed to be first, so we need to move this whole piece, and we take the negative sign with it because that's the number that goes with the 3. And we're going to move it here. So now I'm going to have y equals negative 3x. And then we have to ask ourselves, was this 3 a positive 3 or a negative 3 originally? Hopefully you said positive because there's no negative sign in front of it. So we're going to keep it positive. And we're going to put it as y equals negative 3x plus 3. And we're going to say that this is a positive 3. And we'll check our work. All right, so now it's your turn to try which equations have a y-intercept of negative 4. Take a look at these ones, see if you can come up with the correct answer. Here are your choices. All right. Let's take a look. So initial value of negative 4. So we're looking at the b in our equation. That's a 5, so that's not it. This one's not written correctly, so we'll come back to that one. This one is a 5, so that's not correct. If we were to switch, this negative 5 would go in front, the negative 4 would go second. So it would just be b, the second one only. All right, let's jump into part 2. Okay. So here we have a graph that represents a function described in words. So we have Josie who has 1.5 cups of water in her watering can. She fills the can before watering her plants. Water flows into the watering can at a rate of 1 cup for every 4 seconds. So we need to find the rate of change, the slope, the y-intercept, and the initial value, and then finally the rule. That's a lot of things we're going to be pulling out of this. Let's go ahead and break this down together. I'm going to pull all this information into our notepad here. All right. So first, we are asked to understand the situation. So remember, Josie's filling a watering can. She's not actually watering the flowers, so she's filling the watering can. And this is how quickly the water is being put into the watering can. So we're asked to find the rate of change, which is the slope. So let me grab my pen here. And this is the slope. And the rate of change, so they're going to be the same, I guess, asked for you twice. And we can check. Here's one perfect point. Here's another perfect point. We rise 1, we run 1, 2, 3, 4. So our slope is 1 over 4. And that makes sense because the rate of change is 1 cup for every 4 seconds. The y-intercept, let's look right here. It's this point. Why do we know that the point starts here? Hopefully you said because there's 1.5 cups already in the watering can. So this coordinate right here is at 0, 1.5. Okay, 0, 1.5. So the y-intercept is 0, 1.5, or just 1.5, or b equals 1.5. So the initial value is 1.5. So now we need to plug in our equation. So we're going to have y equals mx plus b. Okay, so I need to fill in my m and I need to fill in my b. My m is my slope, so it's 1/4. Oops, that's a 4. And my b is my initial value, my y-intercept, so it's 1.5. Okay, that's how these problems work. So as our last practice together, go ahead and try this in your book on your own. And you should have gotten that the slope was -2 and the y-intercept was 8. Really quickly, your next got it. You would plug in 0 for n and solve because that's how much before she sold any tickets is 0. And then complete and check your work on numbers 1 and 2 for your close and check.